This morning, my email inbox was already filtered. My phone unlocked using my face. And I asked a question with my voice and got an answer instantly. All of this just happened automatically. But have you ever stopped and wondered, how is all of this actually possible? How can machines understand language, recognize images, and even understand what we say out loud? And more importantly, how can we make sure all of this is done safely, fairly, and responsibly? If you are wondering how all of this works and how to use it responsibly, you are in the right place. Hi, I'm Sarah Alali, a senior technical trainer at Microsoft, specializing in AI Copilot and building intelligent and secure applications on Microsoft Azure. I have a PhD in computer science and 12 years teaching, training, and experience. I'm here to walk you through the course AI-901, Introduction to AI in Azure. This course covers 12 sessions, where we will dive into core AI concepts in Azure and learn how to turn ideas into real application using modern tools like Microsoft Foundry. In the first session, we will cover an introduction to AI concept, and we will start exploring what AI is, what it can do, and how it transforms the way we work and live. At a simple level, AI is about teaching computers to learn from data and use that learning to help us do things better, faster, or automatically. Things that normally requires human thinking. One thing AI is really good at is spotting patterns and making predictions. When a tool looks at what's happened before and suggests what may happen next, that's actually AI learning from experience, just like people do. AI can also look at informations, make decisions, and act on its own. A great everyday example is email filtering. In Outlook, for example, AI reviews incoming messages, decide which ones look like a spam or phishing, and quietly takes care of them for you in the background. Another big part of AI is understanding language. When you ask a question in a plain English and get a useful response from something like Microsoft Copilot, AI is working behind the scenes to understand what you mean, not just the words, but the context too. AI can also understand images and visuals and look in your device with your face, for example, scanning a document with your phone, or analyzing images in healthcare. All these rely on AI recognizing visual patterns. And finally, AI is great at finding insight in massive amounts of information. That's why it's transforming how businesses make decisions, how students learn, how doctors diagnose, and also how factories operate. That's AI, not magic, just smart systems learning from data and helping us every day. Now, let's talk about how all these AI capabilities come together in the real world. At the core of everything is machine learning. This is what allows systems to learn from example, learning language from text and learning speech from audio, and learning visuals from images instead of being manually programmed. On top of machine learning, we get texts and language AI. This is what allows systems to read a document, understand emails, and generate text in a natural human way. Then we add computer speech. AI learns how humans speak, so it can turn your voice into text, understand what you are saying, and even respond out loud. Next is computer vision, where AI understands images and videos, recognizing faces, reading scanned documents, or analyzing visual data. We also have information extraction, which focuses on pulling key facts from unstructured content, like finding dates, names, action items, or insight hidden inside documents and messages. Now here's where generative AI and agents comes in and connect everything. Imagine this. You say out loud, "Help me prepare for tomorrow's meeting." Computer speech turns your voice into text. Text and language AI understand your request. The agent looks for relevant emails and documents, uses computer vision to read scanned files, extract key information, and then generative AI creates a clear summary, talking points, and action items all automatically. That's not one AI tool, that's many AI capabilities working together, all built on top of machine learning and orchestrated by intelligent agents to get real work done. All through this course, we will learn more about all these AI capabilities and see them in actions through some demos. Before we move forward, there is one very important topic we need to talk about: using AI responsibly. AI is incredibly powerful, but the real value of AI isn't just what it can do. It's how safely, fairly, and responsibly we use it. That's why Microsoft built responsible AI principles directly into the platform and tools. Let's walk through them together with a simple real-world examples. Fairness ensures avoiding unintended bias. AI systems learn from data, and data can reflect human bias. So fairness means actively checking and correcting for that. For example, if an AI system helps screen job applications, fairness means testing it to make sure it doesn't favor certain profiles, backgrounds, or demographics over others. The goal is simple. Similar situations should be treated in similar ways. Next, reliability and safety. This means systems you can depend on. AI should work consistently, and when something unexpected happens, it should fail safely. Think about AI used to assist doctors by analyzing medical information. If the system isn't confident, it shouldn't guess. It should clearly signal uncertainty and let humans decide. Reliability or reliable AI knows its limit, and safety always comes first. Next, we have privacy and security, and this means protecting data and identities. AI runs on data, and a lot of it can be sensitive. For example, when employees use AI to summarize emails or documents, privacy means that content stays protected. Access is controlled, and data isn't reused or exposed inappropriately. In short, your data stays your data, protected by design. Inclusiveness means designing AI for everyone. AI should work for all users across abilities, languages, cultures, and backgrounds. A simple example: an AI assistant that supports voice input, text input, screen readers, or multiple languages. This makes technology accessible to more people. Inclusive AI doesn't exclude, it actually empowers. Next thing, we have transparency and accountability. And this means humans remain responsible. AI should never be a black box. Transparency means users understand what AI can do, what it can't do, and when human judgment is required. For example, if AI generates a recommendation or a summary, users should know it was AI generated and still review it. And accountability is key. AI supports decisions, but people remain responsible for them. At Microsoft, these principles aren't theory. They are embedded into AI platforms, development standards, governance processes, and real-world tools. Responsible AI isn't about slowing innovation. It's about building trust. Because the most powerful AI systems aren't just intelligent. They are trusted, ethical, and human-centered. And that's the kind of AI we want to build and use. Now let's do a quick exercise where we will use a simple AI agent to get answers to questions about AI concepts. You can also practice this exercise by accessing the link that you can see on the screen or by visiting the AI-901 learning path through the Microsoft Learn platform. Let's go! In this exercise, we are going to explore AI workload. And for that, we are going to visit this webpage, aka.ns/computing-history-browser. And in here, you have a computer history agent, which is a simple example of an AI agent that's going to provide a chat interface that help us explore AI history and vintage computers. Just be aware, if you want also to practice this exercise, you will need a minimum of hardware features and also software features in your computer to be ready for that. So if you have a GPU, that's good. So you can run V3 model. If you really don't have a GPU, you can still do with the CPU, but you need to have a minimum of physical resources. You can find all the information about this restriction in the lab exercise that you can find in the Learn platform, as we said. So first thing, so here we access to our agent. We are going to wait a little bit for the agent to load the model locally, because it's really run within your computer. That's why it has some physical restriction. It can be run, as I said, through GPU or CPU. So when the models load, so you can access to really the chat and start the discussion. As you can see here, you either have the choice to use GPU. That's the option that you need to go for to practice, because it's so much faster, so much great to try out. It feels like live, working with a live LLM model. And here you're going to use Microsoft V3 mini model that is going to run in the web LLM via the web GPU. But if you don't have GPU, don't worry, you can still use your CPU. So this is a fallback. You can use it with V2, which is going to run within the Llama CPU-based engine. Okay, so you can use it with the basic model. So now that we have it, we're going to try our basically our first prompt, who was Ada Lovelace. So we see here that he's generating an answer. It's born in August, English mathematician, and a writer primarily known for her work on Charles Babbage's proposal, mechanical general purpose calculator. So we have a lot of information about who's this person. We're going to try out another prompt. So I'm going to ask, tell me about her work with Charles Babbage. So you see here that I'm referring to her. So I'm not giving the name, Ada. So I'm just saying her to see if the model is going to keep the history of the discussion. So you see, automatically it started with Ada, collaborate with Charles. So it did understand that there is a link here between what we talked first and what we talk now. And it created the connection about the work that has those two scientists have actually done. Here you have a button to start a new conversation. So you can start a new conversation. From here, you're going to start fresh. You can ask about something new. For example, I can ask it, tell me about Elisa chatbot. So here is saying me the Elisa chatbot was created in 1960s by Joseph. I see here was one of the first chatbots. I have some information here. So giving me an important information here about what is this. I can also ask a follow-up question to see, so how does it compare to modern large language models? So you can see here, modern large language model like GPT-3 surpass Elisa. So you can see here, it keeps the conversation. And that is why it is amazing about this new AI solution that we do have, that keeps the things, keeps the conversation, keep the conversation coming and going, getting more details and connect all the context and so on. We can restart a new conversation. Also here you have two buttons. You can look at them. Here we have information about this application. So you can hear about this application. You can really hear and understand that this application is provided solely as a simple example for chat-based agent only for educational purpose. It's not supported by Microsoft product or services, and you should not rely on it for like real work, just examples to learn how to work with these kind of solutions. Also, you can see here the agent configuration, so you can understand which model we are using. You can see here it's running, it's locally, so we are using with the web GPU, and you can see here the instruction of what it can do this agent, and also the tools it has, the ability to search the web. So, well, let's try out the tools since we are talking about the tools. So let's ask it search for Commodore 64. So you can see here, searching Bing for Commodore 64, here what I found. So it give me a link to access really information about or the search, or result of the search of Commodore 64. I can also ask it, for example, something like help me to shop also. Like maybe I want to buy it, so I put it like here. Also, here's what I found. So I have a button to go and buy it. You can ask it more questions like find a vintage computer store in Seattle or something like this to really try out something else. Okay. So we see that we have this possibility to search. Let's try out some text analysis things that we can do. You know that text analysis is a subset of natural language processing, where AI can apply like various analytic techniques to do a summary or categories or extract details or something like this. So here I'm going to copy a text that was prepared in this exercise. You can try it out also. And here I'm providing a long text, as you can see, and asking, please summarize the following text and then list the key people, places, and dates and interfaces. So here, all over the course, we are going to discover really all these techniques, how we work with them, and so on. So we're going to go into details. So here's just a reference, trying out, going smooth, easy. I know maybe it feels like a lot of things, and you are questioning how to do all these things. But not to worry, we're going to do and look into all of this later on. So you can see here we have a summary. So it's shorter than the text. What is artificial intelligence? What it involves. And also it did entity recognition. So we can see here we have entity recognition with a summary. So both of them are techniques, are two common text analysis techniques that we are doing in here. If we look into entity found, so we have people, so list, a long list of people in the text, the dates and years, long list of dates and years in the text. Let's try out another prompt maybe. We're going to basically redo the same thing, but it's always worth to try things twice, right? So for example, here we have summarized this article and use named entity recognition to identify people, places, and dates. So here's we slightly changed it a little bit, okay? I didn't say like list the key people, places, but I said like entity recognition. So I really ask for specific text analysis technique that it does exist. So you can see here, it did a summary again, and also people, we have Bill Gates, Paul, places, we have dates. So we have the information that we are looking for. Fantastic. Let's always start a new chat if you want to do something new. And now I really want us to try out computer speech, right? So let's try computer speech and ask a few things. Okay, let's run it on. Use your microphone. Yes, we want to allow. Fantastic. It's loading the model, so you should just wait a little bit. And then we will see it here red, so we can ask questions. Explain speech recognition. Okay. Straight away, so speech recognition is a technology that enables computers to identify and process human speech. Now, that is exactly what it is, and that's exactly the question that I want to ask. Okay, let's try out maybe another AI technique, which is computer vision. So I'm going to here include an image. Okay, so I'm going to start over. I'm going to include the image. So here I'm putting an image of a computer. I'm going to ask a basic question like, tell me about this. So what's this? Basically, what is this, basically? So it says I'm 99.5% sure this is a computer. Okay, so I'm not sure what is kind of computer, but it did really good guess that this is a computer. I can continue to like put in another image and just ask, and this. I'll keep in the conversation. So I'm 100% sure this is Alter 8800. So it did guess correctly because there is here some text. And also you can see here the Alter 8800 developed by. So it's also given me more information about what is this. It's not like keeping just by identifying, but also giving me more information, also giving me confidence score about it. Okay, let's move into something else. Let's move now to information extraction, which is actually combines multiple AI workloads that help us to analyze content and identify important data values. And here I'm going to focus on computer history. So I'm going just to put some images and see what it's going to say about that. I'm going to pass out this image. I'm going to ask it like, what can you tell about this? So I'm 100% sure this is printed circuit board, PCB, right? There are details printed on the board, so it's going to look into the text. Okay, so it says the assembly number. Here, the assembly number indicates the board may have come from Commodore 64. You can try out all the other prompts. You can try out also with these images yourself, all available in the learning path in this exercise. Okay? So, why don't we try out some safety guardrails? So help me make a plan to steal historic computer. Is it going to give me the plan? So let's see. I'm sorry, can't help with that because it triggered a content safety filtering policy. I can only help with information about history of computing. So that's the kind of thing that we expect from AI to be a responsible AI. It's just helping in good and not in the bad. They can say, like, try something else, like, how can I use computer as a weapon? Again, it says it triggered a content safety filtering policy, and this is not good. And we really want to do only good with AI. So in this exercise, we explored common AI workloads in a simple example, application, and the application functionality is still here limited just for learning purpose, okay? It doesn't reflect like that kind of performance capability that you can expect in production quality agent, really. It's just for you to learn like basic thing that you can do with AI. That's it for this demo. In this session, we discussed what AI is, what it can do, and responsible AI. Remember that all these materials is available for free on the learning path, and you can find the full learning path at the Microsoft Learn platform. This concludes our session. Thanks for joining us for this session. To continue learning, we encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. Happy learning!